Hi dear students, today we will discuss about design of a riveted joint. First we will go through what we mean by a rivet. Here you can see this rivet. Rivet is a cylindrical component of a round bar. It has one head is there, head part. This is known as tail. This is known as shank or body of the rivet. This component is used to join plate, sheet metal. It's a permanent joint. It is mainly used for fabrication the workpieces. Imagine, okay, if you can take these two plates, consider this is a two plate. For joining this one, these two plate, either you can keep over one another, that is known as overlapping. Otherwise, you can keep nearby like this parallel to each other. After that, by using another plate, you can join. Here also, here I am making the hole. Here also one hole. After we can insert the rivet. In the case of overlapping, we will keep one over another. After keeping certain distance, we are making the riveting. How we make the rivet? If we look at the cross section of an object, you want to join. Just you want to join these two plates. Just you want to join these two plates. You want to join it. If you how will you join it? See the cross section. How can I join? These are plate 1, P1. This is plate 2. Keeping over one another. Then here we can insert rivet here. Then tail end come this side. When you are inserting this rivet here, it like head, shank, tail. After by using hammer or die, you can make a curved shape by using any hammer or some curved shape tool. You die, you can make it here instead of this shape. This shape, it look like a crust of a cone. It will convert into a spherical shape by hammering it. Then for joining these two plates, we are using riveting. This is process on riveting. This is a permanent fastening joint, permanent fastening joint. See, once if you want to dismantle these two plate, either you should go for breaking this rivet. Without breaking this rivet, you can't dismantle this plate. The welding riveting is a permanent joint. Temporary joint example, nut, bolt, studs, screw, that is a temporary joint example. Spigot joint, quarter joint, that are temporary joints. Let us see different type of riveting. See, here you can see that. See, these are a plate 1, 2. One riveting is there. Here they put insert one rivet. Here the back bar is for supporting the head. From tail part, by using die or hammer, we can strike on the head of this part of this tail. They will get it shaped like this. This is the way of doing the riveting. Now look at here. What do you mean by caulking and fullering? Caulking and fullering. See, normally shape it look like this. For making that tight proof joint, we should make this side at an angle or that side made at an angle to avoid the leakage Then by using a blunt tool or cocking tool, it has 80-degree angle. We make like this. Normally it will look like this. By using this cocking tool, we can make an inclined 80-degree angle. We can make the shape. Here also see another tool. This like that we can use two-way. We can cocking and fullering. The cocking may at the tip edge of the one portion of the, not in the edge only, one portion, not full portion, and half of thickness is making with tight proof joint for a tightening inclined position. But in the case of fully at an 80, this usually 80 degree, this 85 degree they are making. Now let us see different types of rivet used in the riveting operation. Then according to its shape of head, we can name it. This is known as snap or cupboard spherical shape. This is a pan head. It look like a frust of a cone. Then conical shape is there. Countersunk head is there. These are the 4 type of riveting normally used riveting operation. Snap head is a commonly used one, and countersunk head is mainly used for shipbuilding operation for hull making. Here is special purpose. That's a conical head. That is counter a conical head. Pan head also we can use wherever you want to make it maximum strength in the joint. There we can use pan head. See now next one, 2 type of joint the riveting. Let us see, these are the plate. 1 plate overlapping, 2 plate overlapping each other. That means we are keeping 1 plate over the another after making the joint here. This is known as lap joint. Another one is known as butt joint. See, keeping 2 plate parallel to each other. These are the 2 plate to be joined. By using another plate, this plate is known as cover plate. We are keeping over the 2 plate and doing the riveting. Doing riveting operation, we can join these 2 plates. This is known as butt joint. Then 1 plate, keeping one plate over the another, doing the riveting, that is known as lap joint. These are the 2 plate, keeping another. By joining these 2 plate, extra 1 more plate keeping over, that is known as butt joint. Now look at here. Here let us discuss about lap joint. Here you can see this 2 plates are there. 2 plate 1, plate 2. 1 plate is keeping over the another. That means both are overlap each other. Then here 1 rivet is there. This is a cross sectional front view. Look at the top view. You can see that rivet. Here 3 rivet is there. But here it is single row of riveting is a single row is there. This rivet is known as single riveted lap joint. It has only single row riveting. That is a single riveted lap joint. Here you can see that here we use once the single row of rivet for joining the plate. Here we are using 2 rows of rivet. This is not double riveted lap joint. Then if we come 1 more rows into 1 triple riveted lap joint, we can name it according to its arrangement of rivet. Next one is this one is double riveted lap joint. But here you can see that these 2 rows are parallel to each other. It is placed in a same line, same horizontal axis only. This rivet and this rivet will come to the same axis line only, horizontal axis. But in the case of double rivet, another type, this is known as zigzag lap joint. This is a line. See, normally here you can see that the first rivet to 1, the same horizontal axis, another rivet is coming in the second line. But here is not coming the second line. Here look at, you can see adjacent in the first this line. If you join in the center of the rivet, this is a rivet 1, rivet 2, rivet 3. If you join the center portion of the rivet, if you draw a line, that line is on a gauge line. This is a gauge line 1, gauge line 2. Then double riveted lap joint, there is a 2 gauge line. but in the case of single riveted lap joint there is only one gauge line. Then look at the first gauge line. Here you can see the one riveting is there. In the same gauge line, adjacent rivet you can see that. But in between first rivet and second rivet, in the mid portion is a midpoint. In that, if you draw a line through the midpoint, in that axis will come the line which is intersecting the second gauge line. There will come the riveting in the zigzag. It moves in a zigzag position. Zigzag. The single riveted lap joint. Let us see butt joint. This is a cross-sectional front view of a butt joint. Plate 1, plate 2. Here you can say plate 1, plate 1 and plate 2. For joining these two, plate 1 and plate 2, one more plate is kept over the base plates. This plate is known as cover plate or strap. Here only single cover plate is there. Now consider for naming we should consider only single plate. Look at a single plate. In the single plate you can see that only single row of riveting. Then this is known as single riveted. How many cover is there? From there you can see that only one cover, single cover. Then single row, that's why it's known as single riveted, single cover butt joint. Single riveted, single cover butt joint. For naming, we should consider only one plate. Look at here. Here you can see that for joining two plate, here two plates are kept above and below the base plates. This is a cover plate 1, this is a cover plate 2, cover plate 1. But only if you can look at the plate 1, there is only single row of riveting. This is single riveted double cover, single riveted double cover butt joint. Now look at here. Here you can see that. Look at the first plate 1. Two plates are there. Consider only one plate. Here is two rows of riveting is there. It is not double riveted. How many cover plate is there? 1, 2. Then double riveted double cover butt joint. Here another one is there. Two plates. For joining two plates, you can see that one plate, two rivets are there, but it is not a chain type, near by near, connected by another. It is zigzag type. Then double riveted, double cover, zigzag butt joint. Now look at here. These are two plates. Joining these two plates, other two plates are keeping above and below the base plate. Look at the one. Consider one plate. Count the number of rivet 1, 2, 3. Then this is not triple rivet. One plate there is a 3 riveting. 3 rows are there. That's why it's known as triple riveted. Double cover. You can say cover 1, cover 2. Double cover, but it is not equal width, unequal width. Then that's why it's known as triple riveted, double cover, unequal width butt joint. Now we will go for the terminology, technical term, which is commonly used in riveted joint. See, this is a gauge line in a single row of riveting. If you join the center of the rivet by a line, that line is known as gauge line. Distance between the center of adjacent rivet, which is measured along the gauge line. This is known as pitch. See, center of the this is center of the rivet 1, this center of rivet 2. The distance between these two center, which is measured along the gauge line, that is known as pitch. Pitch or longitudinal pitch. Now look at here. Here you can say M. M is known as margin. This is a gauge line. The distance between the gauge line and the edge of plate. Edge of plate is known as margin. See, this is the edge of the plate, gauge line. Here only one gauge line, external gauge line, that is known as margin. The distance between the gauge line and the edge of the plate is known as margin. Normally, for finding margin, some empirical relations are using 1.5D. It is represented in terms of diameter. Then here H you can use for represent the thickness of plate, H or T you can use it. Here they are used H for represent the thickness. Now look at here. This is a pitch. Then consider this one is double riveted lap joint. Gauge line 1, gauge line 2. The distance between the gauge line and the edge of plate, this is a margin 1. Here a margin 2. Extreme, the distance between the extreme gauge line and the edge. See, in between you can see the distance, the between. This is margin, this one also margin. The in between, the distance between gauge line is known as, transverse pitch, PT, transverse pitch. The distance between gauge lines. Here gauge line 1, gauge line 2. The distance between the gauge line is known as transverse pitch. This is transverse pitch. Look at here. In the case of zigzag, you can see that gauge line 1, gauge line 2. Then distance between the adjacent to rivet which is in the both gauge line is known as diagonal pitch. Here look at your diagonal ways. Here we have to find this. See, look at here. The distance between the center of this rivet to the distance between the adjacent rivet on the next gauge line. This is known as diametrical pitch. Then there are three type of pitches are there. Pitch is there. One is longitudinal pitch. Longitudinal pitch means the distance between adjacent to rivet which is measured along the gauge line. Next one, distance between the two rivet. Which is on rivet gauge line 1 and gauge line 2. That means distance between the two gauge line is on a transverse pitch. Here in a diagonal way, in the case of diagonal pitch will comes in the case of zigzag type riveting. Now we'll go through different type of failures of riveted joint. See, here in this figure you can see a single riveted lap joint. When it come across a load, when applying the load, what will happen? Due to load, there is a tendency to cut off the rivet. This is a shear off, cut off. Here you can see the single cut. This is a single shear. Then it is known as a single shear. In that rivet, only one cut is there. That is why it is known as single shear. Then the failure of rivet due to shear load, shear force or shear stress is known as shear failure. This is an example of shear failure. Only single shear happened here. Next, tearing of the plate across the rows of rivet. See, here you can see that rivet 1, rivet 2, rivet 3 is the cross-sectional view, top cross-sectional view. If you cut the rivet, you can see the shank like this. Then normally crack will propagate in between these two shank. Shank means the body of the rivet. In between where then tearing, crack will propagate in between the rivet. That is known as tearing across the rows of rivet. It is mainly happen due to tensile load. Next, tearing of the margin. From next we can say, I already explained what we mean by margin. Margin is the distance between the edge of the plate and the gauge line. This distance is known as margin. Normally crack will propagate along the direction of margin. That is known as tearing of margin. Next, crushing of rivet holes. Look at here rivet holes. The rivet hole normally it is a circular shape, but after a long time when it come across the fluctuating load, the circular shape of the rivet hole become oval shape due to vibration and all. Then it leads to failure. This is known as crushing of the rivet or rivet hole. Then just keep in mind, then in the case of a rivet, mainly it is designed based on three type of strength: shear strength, crushing strength, and a tearing strength or tensile end. Three type of load may act. One is tensile load, other shear, next one is crushing or compression on the hole, rivet hole. Strength of a joint. Then normally the strength of a rivet is defined based on the type of load acting on the plate, either shear, crushing or tensile. Now for calculating the strength, we should know about the nominal diameter of the rivet. Opposite. Nearby that park. Yeah. No. Right. Look at here. Let us see the efficiency of the joint. The efficiency of a rivet joint is a ratio of least strength of riveted joint. Least strength means you have to calculate shear strength, crushing strength, tearing strength. Among these three strengths, you have to find out the which is having very small value. Among tearing, crushing, shear load, you have to find out the lower value divided by the tensile strength of a solid plate. Solid plate means we are considering one plate without any rivet hole, normal solid plate. That ratio is known as efficiency of a riveted joint. Therefore, finding the efficiency, you have to find out the lowest value among these three strength. The strength, shear strength, tensile, crushing. Find out the lowest value divided by the tensile strength of a solid plate. Then you will get the efficiency. Listen here. Already the formula is already given in the data book. For finding the TS strength, you can see that the equation P minus D T into sigma theta. P means pitch, D means diameter of rivet, H means thickness of the plate, and sigma theta means tensile stress. Then you will get it tear strength. For getting the shear strength of the rivet, equation is here 1.875 I2 plus I1 into pi t square into tau divided by 4. But in our data book, in the Lingai data book, you can see that instead of 1.875 they use 2, because this value is used mainly for Indian boiler regulation, the standard value. But we are following the SI they are used instead of 1.875, 2 is they are used. Let us see what you mean by I1 and I2. What do you mean I1 and I2? Look at this figure. This is a single riveted lap joint. Then a single row of riveting. Here, look at here. When you load applying both sides of the plate here and here, then there is a chance of cutting the rivet at this direction in this plane. There is single shear. Cut may happen here, only single shear. Then this is known as single shear. Here, look at here. Here two rows are there. Then here also single shear only. Here also single shear happen. But if you look at here, a single shear happening here. Now consider this one is a single riveted double cover butt joint. Here you can say if you consider one rivet. Consider only one rivet. In that one rivet, there are two cuts are there. When you are applying door, here is a shear may occurs here and here. The two cut way may occurs. That's why it is known as double shear. Look at here. This is a rivet. Due to load, it may cut in two pieces. This is known as single shear. Due to apply load, the rivet may cut into two pieces, three pieces. 1, 2, 3 pieces are there. Two cuts are there. Here only single cut. This is known as double shear. Double shear. Keep in mind, in the case of lap joint, there is only single shear. In the case of a lap joint, there is only single shear. There is no double shear. Double shear will come in the butt joint with the two cover plate. Butt joint with the two cover plate. Here you can see that butt joint with the two cover plate. But you considered butt joint with the single cover plate. Here only single shear. Single cut may happen, of course. But here two cut is there. That's why it is known as double shear. I1 is equal to number of rivet in single shear per pitch length. That is known as I1. I2 means number of rivet in double shear per pitch length. That is known as I2. Number of, keep in mind, let us see. Let us consider this figure. This is a single riveted lap joint. Here you can see the top view of this riveting. There is a single row or riveting, that's why it's known as single riveted lap joint. You have to find out number of rivet. I1 means number of rivet in single shear per pitch length. What do you mean pitch length? See, I already explained. Pitch length means the distance between longitudinal pitch length, distance between center of adjacent rivet. See, this is a rivet 1, rivet 2. the distance is known as pitch. We have to find out per pitch length mean one pitch length. This is a one pitch length. If you consider, see, this is a one pitch length, the another pitch length. The pitch length 1, pitch length 2, you can see 1, 2, you can see that. You have to find out what is I1, number of, here you can say only single shear, only single cut is there, single shear. I1 means number of rivet in single shear per pitch length. You have to find out in one pitch length how many rivets are in single shear. This is a one pitch length. Now you have to count it. In one pitch length, this is a rivet 1, but in rivet per pitch length only half portion is coming. Only half. Here also half is coming, not fully. If we look at here, if we consider this pitch length, the center of these two rivet, if we consider this length, this pitch length, you can see the half of first rivet, half of second rivet is coming. If you join these two half, if you joining these two half, you will get a single rivet. Single rivet you will get it. Then numbers of rivet in single shear is 1. In the case of single rivet lap join, if you join half half, there is a 1, you will get it. Now we can consider, you consider double riveted lap joint, chain type, nearby you can say double riveted. This one also single shear. In the lap joint there is only single shear only, but you have to find out I1. I1 is number of rivet in single shear, you have to find out. See, we are considering, this one is a pitch length, per pitch length, you can count it, this half, and this one, and this one. Oh, I already shaded the rivet portion which is comes inside the one pitch length. This is one pitch length. Then we can count how many rivets are there. Only single cut may occurs here. Then you have to find number of rivet in single shear per pitch length, one pitch length. In one pitch, how many? This half and this half will join one rivet. Then here will come one rivet. This and this half will join it. It will form another rivet. This another one rivet. Then 1 plus 1 is equal to 2. Then I1 is equal to 2. I1 is equal to the number of rivet in a single shear. This half and this half will make a 1. So this also 1. 1 plus 1 is equal to 2. Then double riveted lap join, number of rivet in single shear is equal to 2. What about I2? Is equal to 0. Why? Because in the case of